Some books are on a cable and they are swinging in a pendulum-like motion here. And we catch it at a moment where we're at a 25-degree angle to the vertical, traveling at 10 meters per second. And we want to find out what is the force tension in the cable. That's our first question. And we want to know what is the tangential acceleration at this moment. Okay, well, of course, we are doing a circle here. It's a horizontal circle. So we do need to know the centripetal acceleration. So centripetal acceleration is going to equal the mass times velocity squared divided by r. See, the mass is 6 kilograms. Velocity is 10. So 10 squared. And then we'll divide that by the radius of 2. Okay, and that equals 300 meters per second squared. Okay, we'll also need to know the gravity effect, so we better calculate the force of gravity. So force of gravity equals 6 times 9.8. And that equals 58.8 newtons. Okay, so the tension force, of course, is pulling in this way. So the tension force has to apply the centripetal force going inwards. But what part of gravity does this tension force have to account for? Well, we draw a vector straight down, as always, is force gravity. And then we'll draw our triangle, because we will, again, have a component of gravity. One, of course, will be going this way, and one will be going this way. We could use the same notation that we used for when we did inclines. So let's call this one force gravity in the y direction, and let's call this force gravity in the x direction, if we just simply rotate our coordinate system. And of course, the angle theta will be here. Well, this is our force gravity vector. This is the adjacent side, so then that'll be cosine. So force gravity y is going to equal 58.8 times the cosine. Our angle is 25 degrees. And that's 53 newtons. Let's calculate our force gravity x. Force gravity x will equal 58.8 times the sine of 25. And that equals 24.8 newtons. Okay, so now since force gravity y is pointing away from the center of the circle, that means the tension force has to then pull that book this way and oppose gravity. So the force tension is then going to equal force centripetal plus force gravity y. Okay, well, our force centripetal is then going to be equal to our 300, and that should be newtons there, so I'll X that off there and make that a newton. So equal 300 plus, let's see, we have to then take the 53, so that equals 353 newtons. Okay, now what about this force gravity x? Force gravity x is opposing the motion of these books going upwards. And again, we'll assume that there's no air resistance here for this. We want to calculate the acceleration of the books going this way, and that'll be the tangential acceleration. We just go back to Newton's second law, F equals ma. Our force is 24.8 newtons equals 6, which is the mass of the books, times a. And the acceleration is going to equal 4.1 meters per second squared.